Hi, my name's John. I'm a die maker with Corbin Manufacturing. We make bullet swage dies, as I'm sure you're familiar. Today we're going to do an instructional video regarding metal tip bullets. They've become very popular in recent years. Unfortunately, for some would-be bullet makers, there's some misconceptions about the steel tip bullets. So we're going to engage this process and see if we can't make it happen for you. The most important thing about a metal tip bullet is having the correct core volume. The tip itself has a stem behind the bullet point, and it's imperative that when the bullet finishes, that the lead, or whatever your core material is, typically lead, completely comes in behind that tip so that it can anchor the tip with the lead core. If you have too much lead in the jacket, it will actually extrude some out behind the tip, and you'll be left with a little gray lead ring between your tip and the bullet jacket. If you don't have enough core, then what happens is you end up with a void behind the tip and possibly not enough lead in there to anchor the tip well enough. So what we're going to make today is a 308 steel tip bullet with a rebated boat tail. Now, in some cases, we know exactly what the core volume is supposed to be because we've done the experimentation on our own, but we can't give you that information for every jacket and every caliber. Today we're using the Corbin 30 caliber by 1.15 inches long. Since the metal tip bullets can end up being quite long because of the length of the tip, we're using the shortest of the Corbin jackets. We also make these in 1.250 and 1.360, I believe, but I'm using the 1.15 so it can be manageable. We know that with the 30 caliber in a Corbin jacket, that when the core is seated in the jacket, whether it's a flat base or whether it's a boat tail, that the level of the core inside the jacket is about 100 thousandths from the surface. It's a very, very shallow core seating. If you were making an open tip bullet, you'd be quite a bit deeper down in that jacket. The jacket varies in its wall thickness as you go towards the bottom of the jacket. It's thinner at the mouth, it's thicker at the bottom, and there's a certain progression to it. It's imperative, any of you who are familiar with making jacketed bullets, especially using our methodology and our dies, you know that one core seat punch is not going to seat cores in various depths because it won't fit the jacket at all those depths. A core seat punch needs to seal the jacket. It needs to be snug in the jacket to keep the lead from escaping around the punch. But if the punch is too large, then it will tend to jam up in the jacket, and if it's way too large, you can end up actually putting wrinkles in the side of the jacket. So one of the critical aspects just across the board in jacketed bullet making is to have a core seat punch that fits that jacket right where the core is. And you could end up looking like a Mexican bandit with a bandolier full of core seat punches if you're going to do a lot of 30 calibers, for instance, with various jackets, various core depths, open tip, metal tip, hollow points, things like that. So that said, we know that for this jacket and these tips, we want a core that weighs about 169 grains. And I like to measure cores by their length. That's easier for me to do than keep putting them on the scale. Once I get one that's right, then I can check them with my dial caliper or something. That's 1.206 is what it comes out to. I have some pre-cut blank cores that were cut in the Corbin core cutter. and they're just slightly longer than what I really need. And so at that point, I put them in a coarse wage die. Coarse wage die for a 308 is 250 diameter, and I swage the cores, and I uniformly make as many as I'm going to do in the batch run. I cut the cores longer than what I need. I don't want to waste too much lead, but I want to be able to get a good firm bite on that core. So previously I made several cores. If you've made jacketed bullets, you know what I'm talking about. One extra thing I would add is you've got to, if you want consistent results, you need to be really consistent with each step of the process. And beginning with the cores, if your cores vary very much at all from one to the next, you're going to be all over the place when you're trying to seat that core, because the cores are going to seat at different levels in the jacket, and that's just going to be very problematic. So having pre-swaged some cores to the size and weight that I need, for those of you familiar with rebated boattail bullets, there are two core seating dies. There's a B1, which preforms the base of the bullet. We call it the me-plat, the flat end on the base. This is a B1 that has been core seated. The whole purpose of the B1 is to produce a shape and preform that me-plat, so that when we go into the B2 die, and we'll do a B1 or two, and then we'll do a B2, the B2 punch on the inside of the B2 die has the rebated boattail socket in it. And this bullet, as seated in the B1, needs to fit in that socket and register all the way to the bottom. That's why we preform it. You can't just stick a jacket in the B2 die. All it will do is shear it and damage the jacket. So the B1 is an essential part of the process. So that said, I'm going to take a B1 die, and it's a shaped die. It's done in the same machine as our point form dies. It just uses a different reamer and a different lap to finish the die, but it is nonetheless a shaped cavity. Normally when we ship a 308 die set, just generically, we send out a punch a core seat punch that's fairly generic in its diameter, and it works most of the time, depending on what the end user intends to do. The size of that punch is about 1765, 2765, 277. Because of the very shallow seating of this B1 and the fact that we can only be about 100 thousandths from the mouth of the jacket, this particular core seat punch is 284. That's quite a bit bigger, and that's because we're way out in the thin part of the jacket. So I'll take a jacket, put a core in it. And one thing about core seating, you discovered, I'm sure, that if you want the core to remain, or the seated core to remain in the die, you lubricate the core seat punch, because you want the seated core to stay in the die so the punch will come clear of it. Otherwise, what can happen is it'll stick on the punch, and sometimes you have devil of time getting it off of there. You want to use very, very little lube in the die. You want enough to accomplish the seating, but not so much that it won't let you out. I'm going to go back in. I'm discovering my depth of core seating here. Once I get there, then I can process the rest of them. Okay, I think I'm there. Okay, at that point, I think I can put a little more pressure on it. At that point, I want to lock my punch holder. Yeah, that looks like what I want. So the rest of them should follow suit. You want to put just a tiny bit of swage lube on this Corsi punch, the external one, each time, because it tends to push it right off as you go down into the jacket. Now we'll change out the dye. Got myself nice and tight here. We'll still use the same punch, but we're going to go from the B1 to the B2 and finish the rebated boattail part. Now, as to how much definition you can get at the base of the bullet or at the rebate depends largely upon the jacket you're going to use, how thick it is, how pliable it is. And so it stands to reason, and it's true, that a thick-walled jacket is going to give you less definition in those corners. This will give us fairly decent definition. So we're going to reintroduce our Corsi punch. We're going to find the happy place in the B2 die. If you have a thinner jacket and you persist in trying to get very sharp definition here at the rebated base, you're likely to sever the jacket. And you won't even know that it's happened sometimes until you come out of there and you attempt to remove the seated core from the B2 punch, and it leaves the little brass cup or copper cup in the socket of the punch because you've actually cut it off there. So this is just about what we're going to get as far as definition goes. Now, if we were to lead slug this, we would see very sharp corners, but then the lead is very pliable, and it's actually a liquid of sorts. So now we should be able to process the rest of these and get the same thing. think I'll leave one of these out. There's a B1. Okay, so now we've got our B2 seated cores that we've now put the rebated boat tail on the back of the bullet. Now we're going to go into the point form die. Now you go in the point form die 2 times. The first time, we're going to create a socket in the nose of the core that will receive the stem on the metal tip. And that is a punch that has, it's an ejector punch, and it's synchronized with the point form die. It sits up in the cavity just a little bit. And when we pre-form our point form, we're gonna push that bullet down in there until it's just about flush with that shoulder. And what that'll do is it'll put us just almost all the way home as far as anchoring the tip. But we're gonna stop right there, and that will allow us to insert the tip and then go back into the die, but we'll have a different ejector. It won't be this one. It'll be this one that has a small socket in it that sits well below the cavity, and its sole purpose is to push the finished bullet out without damaging the tip. So first we'll process them through. We'll make our preliminary socket with this punch. Once again, once we get the first one, then the rest of them are easy. In this S-press, this synchronized punch has the look of an internal punch, like the B2. It's got the same base on it, and that's because it has to go up and down with the die and stay synchronized. Where commonly with a point form, those of you who are pretty familiar with the press, your point form ejectors typically have this kind of a base, and it's anchored in the press frame, and it does not go up and down with the die. And so that's why we use this to eject the bullet, but we can't use this type of a punch to do this kind of an operation, because the punch needs to go up and down and stay synchronized with the die. Sometimes that question comes up, how come 2 different kinds of punches? That's why. So now I need my rebated boat tail punch. And it has the rebated boat tail socket in it, identical to the one in the B2 die. And the reason the point form has to use the same kind of a punch is it's got to support that rebated boat tail that we've already formed. If we tried to use a flat base punch on it, it would distort the boat tail in the back. Point form dies typically like plenty of lubrication. These, for the metal tip, aren't nearly as critical as some are. Let's see where I am here. Quite a ways to go. Now, I'm going to show you, we aren't all the way there yet, but you can see what's happening. We're bringing the lead down towards the front of the bullet, and the farther we go, the closer the lead's going to be to the mouth of the jacket. And we'll get, when we get there, they're going to be just about flush. Slippery fingers here. Just about perfect. Okay, here we are. There's a little bit of lead flashing right here at the mouth. I'll probably back that off a little. But you can see that we've just come down against the shoulder on that pin. Plus a hair, I went just a little bit deep with it. So I'm going to back it up. And then we can go in with the rest of them. Yeah. Got enough lube on these gloves. I don't think I need any more. Okay, so now we'll switch out the die, or switch out the ejector. Put this one in. Really. This ejector does not contact that tip until we're pushing the bullet out, so it's not part of the forming process at all. All it does is get the finished bullet out of there. All right, so now we take our B2 or our preformed bullet, and we push the tip in a little ways. That hole that we created for the stem, it is very slightly tapered. It's about 5 thousandths bigger than the stem at the front and about 5 thousandths smaller than the stem in the back. And that allows us to stick it into a taper and it'll hold on to it. And so the tip doesn't fall off. Now we can go all the way home with this thing, and distance is really not so terribly critical. Because what I want is a kind of a firm seat on that. There we are. You don't want to put too much pressure on it because it's a blind die now. And if you persist in tightening the punch holder, you can end up bulging the bullet out in there. And then you've got an oversized bullet. It's very unlikely that the bullet would stick in the die because you've got a very positive release pushing it out. If this were an open tip bullet and you ended up with an oversized bullet in the die, you could end up with a bullet stuck in the die. It's not really that common for people to stick bullets in dies, but I suppose that probably 20% of the dies that get sent into us to for service It's because they've stuck a bullet in the die and they didn't know how to get it out. And we're planning on doing a video about that. How to get a stuck bullet out of the die. There's another one. We've occasionally had some people really get them stuck, but you won't do it with a tip die. Now you see I'm running this punch holder up and down because there isn't enough throat for me to get this big long bullet in and out of there without moving this. We do make an item called a quick change punch holder. It has a T slot in the side of the punch holder, so you can take your punch and just slide it in from the side, do the operation, slide the punch out of the way. So that's a popular item with certain people. And here's our last one. There we are. That's how we do it. There's a lot of people out there making metal tip bullets. Some of them use their own metal tips. I know a couple of our customers have told me that they don't use the steel tips, they use the aluminum tips because their state doesn't allow for a steel tip. We're looking into plastic tips, so that's going to be an interesting alternative. The people that we know that make metal tip bullets, whether they're aluminum or steel, they buy their dies from us, and they have their own configuration. They send us the tips, and then we configure a die that matches their tips. If you're interested in more information on these pretty little flashy bullets, you can get some of the information on the website, and you can also call the office and talk to our willing and able personnel who'd be pleased to help you. I want to reiterate the fact that most of the metal tip bullet producers that at least I'm aware of buy their dies from us to produce their metal tip bullets. And we're very pleased to have them do that, of course. But that testifies to the fact that there aren't a lot of places to get them. So we encourage you to investigate our website, and you may discover all kinds of things you're interested in. Thank you.
If you like this video and you want to see more, leave us a like, subscribe to the channel, and if you have any questions or suggestions for future videos, leave us a comment below. Thanks.